Okay, student, today we shall be solving class 10 chapter 6 theorem 6.1. okay, this is also called Thales theorem, or we say basically proportionally theorem also. Okay, in short we say BPT. So now here let us see what this theorem says. If a line is drawn parallel to one side of a triangle, okay, that means what it is given. If a triangle is given here, suppose triangle ABC is a triangle. Okay, in this triangle, if a line is drawn parallel, let's say for example I will draw a line parallel to BC, that means from this point to this point. Okay, for example let us give name DE. Okay, so to intersect the other two sides, that means this line will intersect the other two sides, that is AB and AC. Okay, in distinct points. So that is what in D, AB will be intersected, and at point E, AC will be intersected. Okay, the other two sides are divided in the same ratio. Then what this theorem is saying is that the other two sides, that means this side, okay, this side and this side, will be divided proportionally, that means in ratio. That means AD by BD will be equal to AE by CE. So this theorem is telling us this. Okay, so now they are asking us to prove. So let us prove this. Okay, so let's solve this theorem. Solution. So here what we have, so triangle ABC is given to us. So let us see, a triangle ABC, so in which what is given to us, DE is parallel to BC is already given to us. Okay, here DE is parallel to BC. So let us write here DE is parallel to BC. So this is already given to us. Okay, so now is given, let us write is given. Okay, so now whatever question is telling us is you have to prove that AD by BD is equal to AE by EC. So let us write to prove. So here what we have to prove, so here it is given to us AD by BD, okay, is equal to AE by CE. So we have to prove this. Okay, so now to prove this we need some constructions here. So let us see what construction we need and what are the steps we are going to do here, so that we can get our answer this. Okay, so let's see here. First let us construct. So in triangle ABC we can see D is parallel to BC. So now here one more triangle is formed, ADE. Am I right? So let us draw from point D one perpendicular to line AC. Okay, here that means here it is 90 degree. Okay, and also one more perpendicular, that is from C to line AB. Okay, here also we have got one perpendicular. Okay, so now also let us join B, E and also D and C. Okay, so now you see here what we have got here. We have joined our D, we have drawn perpendicular from D to line AC. No, let us give a name, that is M here, and suppose here it is N. Okay, E and perpendicular to AB, and B, E and C, D are joined. So let us explain this. So let us write it out. Construction what we have done. So what is the construction we have done? That is, what we have done is we have drawn DM perpendicular to AC. So let us write draw DM perpendicular to AC. Okay, and also we have drawn EN. This EN is also perpendicular to AB. EN is also perpendicular to AB. And also what we have done, we have joined BE and CD. Okay, and join BE and CD. Okay, we have done this much construction. We have already explained here. So now let us prove. Okay, so let's prove. So here, proof. So here to prove this, so what we are going to do here, we can see here ADE is a triangle, and what we have drawn DM is perpendicular to the triangle ADE, as well as EN is also perpendicular to triangle ADE, and we are having here one more triangle, that is BDE. It's not that we can say BDE, this triangle. So now you see, if we see, we know that area of triangle is equal to half into base into height. Am I right? So now let us see here. Let us try to identify the heights. So how we identify the heights? See here, there are two types of triangles where heights can be drawn in two different parts. Okay, in two different places. So we have to see this. So let us see. If our triangle is having all the three angles less than 90 degree, okay, if it is less than 90 degree, so let us see. For example, we have got one triangle which is less than 90 degree. Okay, for example, you say ABC is a triangle. So if all the angles are less than 90 degree, then you should remember that our height of this triangle will be inside that triangle. Okay, it will be inside the triangle. For example, you can draw from A, you can draw perpendicular to BC. That means this will be the height. You can draw this way, or you can draw from C perpendicular to AB, or you can draw from B perpendicular to AC. Okay, in three ways we can draw. So here we are going to use what is required to us. So we need two heights. So we are taking two constructions of height. Okay, and similarly, one more triangle is here whose heights will not be inside the triangle, it will be outside the triangle. So in the type of triangle, which triangle is having any one angle more than 90 degree, then we should remember that the height of that triangle will be outside the triangle. Okay, so for example, let's see here, if this is a triangle, okay, like this, if this is a triangle A, B and C, okay, if this is a triangle, then see here, this angle is more than 90 degree. Am I right? So what happens here, in this triangle, our height will be outside the triangle. So let us see, where shall we find this height? So you have to extend this AB more, like this, straight. Okay, and from this C you will have to draw one perpendicular. Okay, and this is the height of this triangle ABC, because here in this triangle ABC, angle B is more than 90 degree. That's why the height of this triangle will be outside. Okay, we'll have to remember this. And if all the angles are less than 90 degree, okay, are less than 90 degree, then you should know that the height of the triangle will be inside the triangle. Okay, so I think this is clear for you. So let us use this property and we shall be solving this. Okay, so okay, now let us prove. So we know already the area of triangles, am I right? So now let us take area of triangle ADE, okay, and area of triangle BDE. We will take these two triangles area in ratio. Okay, so for example, let's try like this. Area of triangle ADE by area of triangle, we are taking ADE, this area of this triangle, by area of triangle BDE. Suppose first this one, okay, that is BDE. So what will be the area? So we know already area of triangle is equal to half into base into height. So let us see, in triangle ADE, what is the formula? It will be half into base. So what will be the base of this triangle ADE? If I'm taking say EN is the height first, okay? EN is the height. Then what will be the base? AD will be the base, okay? EN is the height and AD will be the base. So let us write. So we have got already area of triangle is equal to half into base. What is base? AD. We will get here AD into height. So what is the height? EN. So let us write it EN, okay? By, so similarly what we are having here? Area of triangle BDE. So BDE. So now you have to look here very carefully. So what we will have here also same thing, half into base. So which one is the base now? BDE. So now you can see in triangle BDE, this one. This angle D is more than 90 degrees. Am I right? So this angle D is more than 90 degrees. So our height will be outside the triangle. I have already explained you. Am I right? This now, if we have got any one angle more than 90 degrees, for example A, B, C, if our angles, any one angle of this triangle is more than 90 degrees, I have told you already, our height will be outside the triangle. So how we will get? So you can see here this one. This will be the height. Am I right? So here also similarly when we see BDE, so this angle is more than 90 degrees. So our height, where can we find? We have to extend this BD up to, it is extended more, and what? EN is the height of this triangle BDE. Okay? So let us write. So here also half into, so what we have got? Base. Which is the base? BD is the base here. So half into base into height. Am I right? So what is the base? BD into height. So what is the height? EN. EN is the height here. So similarly what we are going to have here now, that is area of triangle ADE by area of triangle BDE. So what we are going to have here? So you can see here half, half cancel. What here? EN is also cancel. That means the height is also cancel. So here what remains? Only AD by BD. So we have got here AD by BD. Okay. So let us give this one as number 1. Okay. Similarly, when we look here also, now you see here in triangle ADE and in triangle CDE. Okay. What do we find here? So in triangle ADE, now let us take, suppose DM is the height. Am I right? Then in triangle CDE also we will get what? DM is the height. So now similarly, same thing what we have done here. Similarly, we will be doing in triangle ADE and CDE. Okay. So what we will be getting here also? The same thing. Am I right? Similarly, what we are going to have here? Similarly, so what we are going to have in triangle ADE. Okay, that means what? Area of triangle ADE by area of triangle now CDE. We are going to take this triangle. Okay, that is CDE. So here what we are going to have here now? Same thing. Now we will use DM is the height here. Okay. So if DM is the height, then we know A is the base here. So now let us write it. Area of triangle AD is equal to half into base. So which one is the base? AE is the base here. So AE into height. So which is the height? DM is the height here. Okay. By here also area of triangle CDM. Area of triangle CDM. So what we are going to have? So this is more than 90 degrees. Then this will be extended more. Right? And DM only will be the height of this triangle CDE also. Okay. So now here also what we are going to have in triangle C, area of triangle CD is equal to half into base. So which is the base? CE. So CE into height DM. Am I right? So we'll get here also DM. So similarly what we are going to have here now again? area of triangle ADE by area of triangle here CDE will be equal to, so here we can see half will be cancel out, so here we can see dm is also cancel out, am I right? So now what remains here? AE by CE. We have got this two distances. Suppose this is equation number 2. And now let us see here one more theorem we can see here. That is what we have learned already in class 9. Okay, so what the theorem is telling us, if between two parallel lines, okay, between two parallel lines, if two triangle lies on the same base, for example, if say suppose one triangle lying like this and other triangle lying like this, okay, that means what we can say, suppose AB is the base here, okay, and what CD is another line, that means AB line and CD line is parallel line, and triangle AB here we can say E and F suppose, then you see here what we can get, triangle AEB, okay, this triangle, and AFB, you can see what, this triangle, these two triangles are lying on the same base, am I right? That is what, AB, and they are lying between the same parallels, am I right? Then we will have to know that the theorem tells us that area of the triangle AEB, that means what, area of triangle ABE will be equal to area of triangle AFB, triangle AFB. So you will have to know this, okay. This theorem is giving us guarantee. So if two triangles are lying between the same parallels, okay, between two lines which are parallel to each other, and if they are lying on the same base, then what we can say, area of these two triangles are equal, okay. So I think this is clear for you. So now let us solve more again. Okay, then let me solve this side now. So here, now you see here, also we have known that area of triangle BDE, okay, these two lines, we know DE line and BC lines are what, parallel lines, we have already drawn, so it is already given to us, am I right here? DE is parallel to BC, DE is parallel to BC, and we know triangle BDE, this triangle, and CDE, this triangle, is lying between the same parallels, am I right? And they are having the same base, that is D, common base, am I right? Then we have already learned in class 9 that if two triangles are lying between the two parallels, okay, between two parallels, and if they are having one common base, then the area of these two triangles are equal, okay. So let us write it. So then here what we can get here, also what we have here, area of triangle BDE, triangle BDE is equal to area of triangle CDE, that is what, CDE. So if you want to explain, so you can write it very nicely here. So let me explain the reason for this. That is what, triangles lying on the same parallel and having common base, okay. So that means what, triangle lying between the same parallels. We can explain it in this way. So you can write this side, that is triangles, okay, lying on same base and between same parallels, okay. parallels. Okay, that means these two triangles are lying between the same parallel and they are having the same base. Okay, that's why area of these two triangles are equal. Okay, so now let us see again. So let us give, suppose this is what equation number 3. Okay, so now what we are going to do here, we are going to put the value of this equation number 3 in equation number 2 or 1, anyone else. Okay, so let me put it in equation number 2. So putting the value of this equation number 3 in equation number 2. So what shall we get? Okay, let us see here. Then now let me write here. Therefore now putting value of 3 in 2. Okay, now we are going to put value of this equation number 3, okay, in equation number 2 here. And what we are going to have, let us see here. So what we are going to have here, so here we know area of triangle BDE is equal to area of triangle CDE. So here we have got one area of triangle CDE. That means in place of this CDE, then in place of this CDE I can write BDE, because BDE and CDE are equal in number 3. So this value I am going to put in equation number 2 here. So in place of CDE I am going to put here BDE. Okay, then what we are going to have here, when we put in equation number 2 the value of equation number 3, so here what we are going to have is area of triangle ADE by area of triangle, in place of CDE, okay, I am going to put BDE, because these two are equal in equation number 3. So I am going to put this value in equation number 2 here. CD, in place of CDE I am going to replace with triangle BDE, and this is equal to what in equation number 2? AE by C. So here AE by CE. Okay, we have got this. And now you see here what we have got. When we look very carefully, this one, okay, say suppose this one is number 4. So when we look this and equation number 1 here, so what we have got, area of triangle ADE by area of triangle BDE. So here also in 1 what we have got, area of triangle ADE by area of triangle BDE. It's not the same thing we have got. Am I right? So this is equal to AD by BD we have got in equation number 1. Am I right here? So in place of this I am going to put AD by BD here. Okay, then we are going to have the answer. So now let us see. Let me replace. That means what we are going to have, or when I put the value of 4 in what? 1, or value of 1 in 4. So what we are going to have here, in place of this I am going to replace with this. Okay, then in place of this I am going to replace this. So what I am going to have here, AD by BD is equal to here AE by CE. So now you can see here, this one I have already find out what is to prove here. So this is the solution for this Thales theorem. Okay, so you will have to know how we solve this Thales theorem, and Thales is giving us guarantee that if in a triangle, if one line is drawn parallel to any one side of this triangle, suppose this is drawn parallel to this, then we know the sides are what? Divided in the same ratio. That means AD by BD will be equal to AE by CE. Okay, so you will have to remember this always. Okay, and also when we are solving the question, conversely, if it is given to you, suppose AD by BD is equal to AE by CE, then you should know that this line DE will be parallel to BC. Okay, this is conversely. Okay, so now I think you have understood how we have solved this question. Please do like, share and subscribe to learn more maths.